Okay, so a normal distribution variable, random variable which are normally distributed, will be those, we call it naturally occurrence things. Like for example, you talk about your IQ. You talk about the height. You talk about the weight. You talk about a lot of things, naturally occurrence things. Yeah, so we will have most people, or most of the measurement, most of the weight, most of the height, or most of the time taken to solve a problem, okay, will be cluttered around the mean. And we will have, God is very fair to every one of us. So it will be equal number of people, or equal, it will be symmetrical. They will have very, very few people who are very, very low, or they will have very, very few people who IQ is very, very high. So these are called normally distributed. So which means that the first thing is, the shape is the shape of the probability density function for normal distribution is symmetrical. Symmetrical around what? Symmetrical along the mean. Okay? And most of the variable are around the mean. Okay? And very few is much greater or much smaller than the mean. So this means that from here I can conclude mean is equal to the median is equal to the mode. So these three central measures are the same. So that is talk about normal distribution. The shape of the probability density function is symmetrical along the mean. So look, if this is my variable x, okay, if x is normally distributed, we always write n to represent normally distributed, and this is the mean, and this is the standard deviation. And here we usually write standard deviation squared. So they will have a axis of symmetry. So that means the left-hand side, the shape of the graph at the left-hand side of the mean is the same as the shape of the graph at the right-hand side of the mean. Okay, so the highest point, because the mean is the mode, is also the median. Correct? And most of the value are cluttered around the mean. So there are very few very big or very few very small. So, but it doesn't touch the x-axis. Clear? So that's why the shape of the graph is go like that. So this is called the bell shape. And may I know, based on your understanding of probability density function, what is the area of the red region? Can someone tell me? Okay, your friend said is 0.5. Siti, can you explain to Miss Do why is it 0.5?
Because it is the median, more than the median.
Why is it 0.5?
Because the probability of median to the upper boundary is 0.5.
That is the meaning of median, correct? Median means 50% of the value will be more than the median and 50% will be less than the median. Am I right? And we know that sum of the probability is equal to 1. Yep. So half of it will be 0.5 because area bounded by the probability density function tell us the probability. And it is a continuous variable, correct? So that means if I ask you, if I let the mean, so if I ask you, this is a probability density function. Huh? If I ask you this question in the exam, I say I integrate from mean to infinity probability density function dx. What is the answer? What will the answer be? Who is the Nyayo? May I know who is Nyayo? Who is Nyayo, please? Who is Nyayo? You don't answer me, I kick you out of the class, huh? N-A-Y-O. Who is Nyayo? Okay, you don't answer me, I kick you out of my class. Who is N-A-Y-O? Okay, I remove. You don't want to answer me? That's it. Because it's an alien, huh? Don't blame me, so okay? I have to know who are the one that come into my class. So for this case, this means it's 0.5. Okay. So clear? Okay, so now how are we going to sketch the graph? If you look at page 233, there is 2 inflection point here. Am I right? There are 2 inflection point here. So how are we going to do it? And if you look at that page, I'm not going to differentiate for you. You can go and try to differentiate it. So listen here. It is 1 standard deviation away. That is where the location of the inflection point. So when you sketch the graph, you have to sketch properly. 1 standard deviation away. And how am I going to judge the height? Look, how am I going to judge the height? From the highest point, okay. From the highest point, I divide into 3 equal parts. 3 equal parts. So the inflection point will be 1 standard deviation away from the mean and is 1/3 down from the highest point. Clear? That is how you sketch the normal distribution graph. One standard deviation away, the shape of the graph is concave down. After that is convex, concave up. And please make sure your graph doesn't touch the x-axis. Although if you look at page 233, your textbook, right, it shows touches, it's not. So try not to. And for any normal distribution, correct? Okay, so this is one of the characteristics. Where is the location of the inflection point? One standard deviation away from the mean and 1/3 down from the highest point. Around that. I'm not saying exactly around that. Are you okay? That's how you sketch the graph. And the area bounded by the probability density function must be equal to 1 unit. It doesn't matter whatever. So what are the characteristics of a normal distribution graph? Can you please take some time to write it down? Talk about the area. Talk about where is the inflection point. And talk about the relationship between the mean and the mode. Here I written down one already. So this is one of the characteristics. Second one, you write down by yourself. Talk about where is the inflection point. The first one, you must say symmetrical. This one I write down already. Second one, where is the location of the inflection point? Third, okay, second one written down already. The inflection point is located at one standard deviation away from the mean and is 1/3 down from the highest point. Done. And the third one is probability. Probability of X. 3 standard deviation away from the mean. This is called 3 standard deviation away from the mean. Almost equal to 1. So I'm quite sure that, I'm almost 100% sure that all the data will be 3 standard deviation away from the mean. So the graph usually fade off at the point whereby it's 3 standard deviation away. Yep. So that is how we sketch the graph.
Miss, can you repeat the second point again, please?
What is the second point? You ask one of your friends to repeat for you.
Okay.
Call any of your friends. Hello? I know there's one class. Azif, repeat.
Inflection point is 1 deviation away from mean.
1 standard deviation, sorry.
1 standard deviation away from the mean and 1/3 from the highest point.
Yeah, 1/3 down from the highest point.
1/3 down.
Yeah, 1/3 down. If you say 1/3, it can be 1/3 up, 1/3 down. Okay.
Oh.
When you say away means there is a minus, there is a plus. Okay, that is how we use the word away. Okay.
Thank you, Azif.
Yeah.
Miss.
Okay, so these are the characteristic of a normal distribution, probability density function of a normal distribution graph. Okay, the area bounded by the curve must be how many unit? 1 unit. Okay, so now use your, can I move? After I will teach you how to use your graphic calculator to get all the answer. Okay, I can move on. Okay, I want you to spend about 10 minutes. Try to sketch the probability density function for these two variables. One is called the x, which is normally distributed with a mean of 3 and a standard deviation of 2. Okay, I can put like that. Okay, can I change the mean? I try not to. Okay, 10. Okay, and another variable, which is called y, is also normally distributed with a mean of 10 also, but with a standard deviation of 3. Okay, on the same axis. Okay, on the same axis. So which means that you have to plot the graph. This is your x, this is also your y. Understand? Okay, try. Okay. Anyone got the graph ready?
Yes.
Yes. You see the graph? Okay.
The blue line is
The y,
above the red
yeah.
line, right?
Yeah, okay. Listen here. If you are using this, your y2 graph will be shorter and wider. Am I right?
Yes.
And your y1 graph is taller and narrower.
I would
Okay.
say, can I say steeper?
Yeah. Okay, up to you. Okay. Whatever is it. So listen here carefully, class. Why I know? Even I didn't draw the graph. The reason is because I know that the area must be 1 unit. So you imagine this like a rectangle. The standard deviation will be your spread. So you see, x, the spread is smaller, but the area still need to be 1 unit. So that's why it is taller. For y, the spread is bigger. So the area still need to be 1 unit. So that's why it is shorter. You see or not? So how am I going to judge the height? Okay, I will judge the height by using the standard deviation. Okay, now, if the standard deviation is smaller, it will be higher. So that means, you see the standard deviation of x and the standard deviation of y. it go by the ratio of 2/3. Correct? So therefore, the height for y over the height for x, it will be 2/3 also. That means the height for the distribution of y is shorter. So now what I do is, okay, look, this is my axis of symmetry. They have the same mean. Okay, they have the same mean, that is 10. Okay, then I do the distribution. This is 13 here. 16 here. I always use the higher spread. And this is 19 here. Okay, then minus 7, 4, and 1. You see how I do? Okay, then for the height, I just take 3 parts. Okay. Why I take 3 parts? Because here is 3. Okay, so I will start with the x first. Okay, so the x, the highest point is here. So x, I use black, okay, black for x, so the highest point is here. Got it? So that is the first step. Prepare your axis first. Your horizontal axis, always go with the highest standard deviation. Jot it down properly. Yeah. Then prepare the vertical axis. Okay. So determine which is the taller, which is the shorter, according to the ratio given. Okay, the highest point for x is there. So where is the inflection point? 1 standard deviation away from the mean. The standard deviation for x is 2. So here is here. So 2/3, 1/3 down. So this happened to be 1/3 down, okay? This happened to be 1/3 down. So here is the inflection point. You get me? See or not? And here is the inflection point. So that is how we sketch the graph. Done? Okay, then the next 2 important points is the location of the where the graph will fade off. 3 standard deviation away. So 3 standard deviation away for x, it will be 10 minus 3 times 2. That is 4. So here, fade away here. 10 plus 3 times 2. That is 16. So happen to be here. It doesn't mean that always is here. So now I start to draw the shape. Concave, a convex, concave up, concave down, then concave up. This is steeper. And you can move if you want to. That's how I do. So this is the x. So any issue with the x? So now only I draw the y. I always draw the tallest one, but I prepare the horizontal axis, use the highest standard deviation. So for y, I'm going to use the blue. Highest point is here. Okay, 2/3 of this, around that. So 1 standard deviation away. It may coincide, it may not, I don't know. This is a rough sketch. and fade away at 3 standard deviation away. So you see, you just go by order. So convex, concave, and convex. And here should be steeper down. Huh? Okay, you should be able to draw better than mine. Okay, so this is your Y. Clear? So if you sketch the graph using the graphic calculator, it also give you the same. Actually, you can sketch the graph using the graphic calculator without keying in this formula. Do you know that? If you go to second draw, I think you can draw that. I'm not very sure. You go and explore. Okay. You go and explore. You go under second distribution, correct? You go to draw, shade normal. Maybe they can do it for you. I don't know. Okay, you can go and check. Okay, so that is how because in the exam they can prepare the axis and ask you to sketch. Okay, so there are 3 important things. So if they got 2 distribution, they ask you to draw on the same graph. You have to take note of the mean and the standard deviation. Always bear in mind, the total area bounded by the probability density function must be 1 unit. So if the standard deviation is smaller, it must be taller. Get it? Hello? Can or not? Okay, so I have explained clearly how to sketch the graph. Huh? Okay, can you please look at page 234? Okay, page 234. Do you see the graph? Okay, do you need to memorize all that? Is it good to memorize all that? No need. You can write it in your 1-page handwritten notes. If I don't write this in my 1-page handwritten notes, then what should I do? So it doesn't matter whatever normal distribution is. If it's 1 standard deviation away, the chances for it to happen will be 64.26%. That is how I interpret. So whatever normal distribution given to me, okay, 64.26%. That means probability of X between mean minus 1 standard deviation, mean plus 1 standard deviation, the probability is always 64.26%. It's fixed. Yeah. 68, sorry, 68.26%. So if I don't have this, okay, like for example, for in high school, you use a table to find, correct? So now we don't have to use the table to find. For example, I give you a normal distribution. Okay, I say the mean is 7. The standard deviation is 2. Okay, so I say find the probability that X is between 5 and 9. So how am I going to do it using my graphic calculator? So I know this is definitely 68.26%. Or if you write as probability, it will be 0.6826. Am I right? One standard deviation away, 7 minus 2, 7 plus 2. Yep. So how am I going to use my graphic calculator to do it? Okay, please go to second vase. Okay, tell me which one to use. Second vase. Tell me which one to use. First one or the second one? First one or the second one? Yes, it must use the second one because probability for a particular value of variable X to happen, if it's a continuous, the chances is 0. Use this one. Okay, use the second one and you just key in accordingly. This is your lower. This is your upper. Okay, the rest you should know what to key in. Mean is 7, standard deviation is 2. Paste. Do you get that? So we only use 1 for normal distribution. Hello? Ken? Okay, I move to the other one. Okay, so now, if you look at that page also, this is a mean. Plus 1 standard deviation. So if I want this situation, I want probability of X greater than mean plus 1 standard deviation. Can you tell me what is the answer based on your page 243? 234? Can you tell me what is the answer? Here is 0.3413. So how am I going to do this? Can I just take 0.5 minus 0.3413? Then I will get the answer. All right? Because half of the area is 0.5. Okay, how am I going to use my graphic calculator to key in? How am I going to use my graphic calculator to key in? Okay, if graphic calculator you must have, so we go to just now our 7 and 2. Okay, so here will be 7 plus 2, which is 9, okay? So now how are we going to use our graphic calculator to find this answer? So we still go to normal CDF. So now our lower is 9. Our upper, because there is no upper, correct? You are talking about X onward, from 9 onward. So your upper, you have to write down 10 to the power of 99. Are you okay? You have to write down 10 to the power of 99. That means very, very big. You don't care whatever situation, you just write down 10 to the power of 99. Do you get the answer? Okay, so you get 0.1587, right? You get that? So you must know how to key into your calculator. Huh? Okay, can I move to the next one? Okay, if I have a situation like this, okay, our X is still normally distributed 7, 2. Okay, this is the mean. This is mean plus 1 standard deviation. I want this part. I want the probability of X less than or equal to, it doesn't matter, mean plus 1 standard deviation. So our situation will be probability of X less than or equal to 9. Okay, so now, if you look at here, half of the is 0.5, am I right? And here is 0.3413. So the probability here will be 0.5 plus 0.3413. You get your answer. If you have that table, So that the whatever shown in page 234 is just to give you a certain situation only. If any other situation, they can't give you. So this will be 0.8413. So how am I going to key in my calculator for this case? So this is your upper. So your upper is 9. How about your lower? Listen, there is no lower. So we must put negative 10 to the power 99. Please. It's not 10 to the power of negative 99. It's negative 10 to the power of 99. Okay, do you get the answer? Okay, so that is how you use your graphic calculator to find the answer, or you use the table. Okay, now. Okay, so the rest, you just start to do. So actually now you can do even until exercise 8D. Okay. So you look through exercise 8C, 8D. Yeah, so tomorrow I will go through any question that you don't know how to do in this part. Okay? Hello? Then Wednesday I can go to 8E. Yeah. So when do you want to have your SAT for? SAT 5. Hello, student, when do you want to have your SAT 5?